Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. I want to talk about the future of education, a future that moves beyond static digital textbooks and into a new realm of truly adaptive, intelligent learning systems. We are here to discuss a blueprint for building the Synaptic Learning Companion, an AI tutor that isn't just programmed with information, but is fundamentally inspired by the very biological processes that allow us to learn and form memories in our own brains. This is a new paradigm for educational technology, one grounded in the brain's own code. So, why is a new approach necessary? Because for all our technological advancement, digital learning is still largely bound by the one-size-fits-all fallacy. Most platforms today are essentially just digital textbooks. They present static content in a linear fashion, treating every learner identically. Crucially, they ignore the dynamic nature of the human mind. They can't tell if you are focused and engaged or tired and distracted. Your cognitive state is a black box to them. This leads to a superficial level of tracking. They know if you got an answer right or wrong, but they have no real concept of how well you know the material or how that piece of knowledge connects to everything else you've learned. They track the what, but completely miss the how. So, what is our solution? It's to go deeper than surface-level AI. Instead of just using machine learning to analyze answer patterns, we will model the fundamental biological mechanism of learning, synaptic plasticity. At the core of our companion is a simulated neural network where connections between concepts strengthen or weaken based on your interactions, a process known as long-term potentiation and long-term depression. When you learn something successfully, the connections representing that knowledge get stronger. If a connection is irrelevant, it gets weaker. With our neuron models defined, we move into the actual implementation of the neural simulation core. The first critical step is to select the right simulation environment. Tools like Neuron or Arbor are excellent open-source choices, offering a high degree of biological realism while also providing the computational efficiency needed for simulating complex networks. The selection here is a balance between fidelity to biological processes and practical performance. Next, we construct the neural network itself. This isn't just a random arrangement of neurons. Its topology must be carefully designed to represent the specific learning domain. For example, in a language learning companion, different clusters of neurons might represent vocabulary, grammatical rules, or the associations between them. The structure of the network directly encodes the knowledge we want the companion to help the user acquire. Finally, and most importantly, we implement the synaptic plasticity rules within the simulation environment. This means coding the algorithms for long-term potentiation and long-term depression. These algorithms ensure that the synaptic weights, the strength of connections between neurons, are dynamically updated based on the history of neural activity and modulated by signals like simulated dopamine. This is where the learning truly happens within our companion, mirroring how our own brains adapt and strengthen connections. This approach goes far beyond traditional content delivery. It's not just about presenting information. It's about deeply understanding how a learner learns. By leveraging neurotransmitter binding models and synaptic plasticity, we aim to optimize the very neural pathways responsible for knowledge acquisition and long-term retention. We are building a system that learns with the learner, strengthening their understanding at a fundamental, neurological level. Ultimately, our goal is to create a true lifelong learning companion, a system that evolves with the learner throughout their educational journey, continuously adapting to their needs, preferences, and growing knowledge base. This companion will empower individuals to achieve deeper understanding, greater mastery, and a more profound connection with the subjects they are passionate about, unlocking a new era of human potential through intelligent, biological-inspired AI. I am now happy to take any questions in comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.